Welcome to Lesson 73, Part 1. Using a protractor to measure angles, pages 19 and 20. Our content objective for 4th grade MD measurement data is C6. I can use a protractor to measure angles in whole number degrees. Language objective, I can use vocabulary related to circles to describe how to use a protractor to measure angles. Social objective, I can work with others to measure angles with protractors. Okay, so hopefully you have received your protractor. Looks like this. We're going to be practicing with it, but there also are ones drawn on the page to make it a little easier. We'll practice more in our practice page after this lesson. Okay, so a protractor is a tool used to measure angles. So we're taking that circle protractor and just cutting it in half, because I can turn this around to get the bottom part of a circle if I needed to. I just need to add it on. I don't need to have a full circle. This takes up less room, and it can get me what I need because I can just turn it over if I need to. I keep having it backwards, so you want to make sure you have the numbers the right direction. So our steps for using a protractor: line up one of the rays along the 0, 180 degree line at the bottom of the protractor. Make sure the vertex of the angle is at the midway point of the line. So on ours, this is the indicator of our midway point, because that's the center of the circle. Your vertex must be at the center of the circle for it to work. So if you line it up here, and then you may line it up on either this side here, this 0, 180, or this 0, 180. You can line it up either direction. You just have to be aware of where the 0 is. The 0 is at the bottom, so the bottom set of numbers. The 0 is at the top, so the top set of numbers. Then look at where the other ray intersects the protractor. So intersect means, the crossing. If the angle is smaller than 90 degrees, use a smaller number. If the angle is larger than 90 degrees, use a larger number. So another way to tell, if you don't remember to use the bottom set or top set, we got to use some logic and reasoning. If it's an acute angle, the number is going to be the one that's less than 90 degrees. If it's an obtuse angle, it's going to be greater. If it's exactly a right angle, we'll see it right here because they're both 90 degrees. So again, looking at this, you place the vertex at that midway point, because that's the center of the circle. Sometimes it'll be near the top, sometimes near the bottom, but it will be always halfway in between because that's the center of the circle. You line it up at one of the zeros, and then you see where it crosses. Now you can count up to it, or you could just see where it crosses. Since this is acute, you would use the bottom set of numbers, 10, 20, 30, 40 degrees. That's where it lines up, is at 40 degrees. So you need to fill in that 40 degrees right there. The ray crosses the inner scale at 0 degrees. So here it's at 0 degrees. This means the inner scale will be used for the angle. That means the inside numbers, the bottom set of numbers, not the top set or the outside. What is another way to decide which scale to use when measuring an angle? Seeing if it is acute or obtuse to know if it is 40 degrees or 140 degrees. So on here, if I look, if you could see the numbers well, it would look like this right here. this 40 and 140. Well, which number would you use? Well, which one makes more sense? Is this an acute angle or an obtuse angle? It's acute. It's small. It's less than 90 degrees, so you have to use a number less than 90 degrees. This one would make more sense because it is an acute angle. If it was obtuse, then that would make more sense, and it would be lined up on this side to use those outside numbers or the top numbers. All right, so let's practice with these semicircle protractors. So first thing you have to do is make sure your vertex is lined up at that midpoint, because that's going to be the center of your circle. If there is a dot like this, you usually want the dot right on top of it. If you have one of the larger ones, the ones you can buy at the store. So here, it's lined up here. We'd use the bottom set of numbers. You can kind of see them this time. But I definitely see that it's halfway between these two lines. So if you can't see the numbers, you can count. So starting at the 0, 10, 20, 30, 40, 50, 65. The other option is 125. Well, which one makes more sense? This is acute, so the number less than 90 makes more sense. 65 degrees makes more sense. Here again, that vertex is lined up at the midpoint, that center of the circle. 0, we'd actually use the bottom set or the inside set of numbers. Also, this is definitely greater than 90 degrees. It's obtuse, so we'd use the number larger. So let's see, here's 90. It's straight on there. I can kind of see the numbers, but if you can't, we can start at 90, 100, 110, 120, 130. So our options are 130 or 50. It's larger than larger than a right angle, so 130 degrees makes more sense, more reasonable. Okay, here, vertex is at the midpoint. We're at the 0. I could line it up on this side. And it goes all the way to, I can see where it terminates. It intersects at 90 degrees. So this is a right angle. The only ones that get those squares there. Okay. Now we're going to practice also lining up on the other side. So the vertex is always at that midpoint to make it in the center of the circle. Lined up at the 0. The 0 is the top numbers. We're going to use the top numbers this time. Also, I can tell that it is obtuse. So if it's obtuse, I'm going to use a number larger than 90 degrees. So here's it starts at 0, so I can count up to 90. 100, 110, 120, 130, 140, and it's directly at the number, so it's 140 degrees. Now we have a question. Why is the measure of the angle not the 40 degrees? Why is it 140 and not 40? Because it's greater than 90 degrees. It is, or I could say it is obtuse. If it's obtuse, it's going to be greater than 90 degrees. Here, that vertex is at the center. We're lined up at the 0 on this side. So we count up to 90, 100, 110, 120, 130, 140, 150 degrees. So why is it 150 degrees and not 30 degrees? Well, because this angle is obtuse. It is obtuse. And if it is obtuse, that is greater than 90 degrees. 30 degrees is less than 90 degrees. That doesn't make sense. It's unreasonable. Okay, here our vertex is at the center. We're lined up at the 0, and it terminates or intersects here at 90 degrees. So that means this is a right angle, even though it's on the other side. That's exactly half of 180. These two pieces are both 90 degrees. Put together make 180. What fraction degree turn is this? So in a full circle, how many turns are in there? there are 4 90 degrees. So it is a 1/4 turn. Because this is the top part of the circle. 1, 2, and then if I continue the rest of the circle, there'd be 3, 4. So it's 1 out of the 4 turns I could do in a circle. Okay, here we have our vertex at the center of the circle, so the midpoint of this line. This ray is at the 0, bottom set of numbers, 10, 20, 30, 40, 50, 60. It terminates at the 60. It intersects at the 60 degrees. Is the angle less than or greater than 90 degrees? It is less than 90 degrees because it is an acute angle. And that's also why I know not to use 120 degrees because it's an acute angle. All right, let's go ahead and practice some more with measuring with protractors in our 3-column notes.